Hello, this is a weekly summary of interesting news that is relevant for my distributed systems lecture at the Eastern University of Applied Sciences in Switzerland. My name is Thomas Bocek, and today we will discuss 3 topics. And the first topic is about reinventing the wheel. It's the following article here. This article discusses why people should not always follow the common advice to avoid reinventing existing solutions. The author argues that this advice, while well-meaning, can discourage curiosity and exploration in technology development. And this article explains that reinventing something that already exists serves as a learning method. To truly understand how something works at a fundamental level, you need to implement a basic version yourself. The author quotes physicist Richard Feynman, "What I cannot create, I do not understand." And this applies to many concepts in computer science that people assume are too complex to recreate, including protocols, cryptography, and web servers. And the author points out that everyday programming concepts like strings or file paths are actually very complex when you try to implement them yourself. Building these from scratch teaches you that there is infinite complexity in simple things, that creating something useful is difficult, and that all existing solutions involve trade-offs. And when building your own version of something, you must make decisions about correctness, simplicity, functionality, and scalability, performance, resource usage, and portability. You cannot optimize for all of these at once. This means existing solutions also have flaws and might not solve your specific problem perfectly. And the article lists several good reasons to reinvent: building a better version, learning how things are made, teaching others, understanding the original inventors, being able to fix or modify existing solutions, learning the necessary tools, and understanding how components fit into larger systems. The author emphasizes that you should study existing work and reuse it where appropriate. The goal is not to ignore others' work out of distrust or ignorance, but to test your knowledge through building. In software engineering, creating small prototypes is cheap and fast, allowing you to solve your own problems through simple iterations. And this is also the reason why we are doing the challenge task. So we have in the lecture the following challenge task that requires you to implement a distributed systems. And as I mentioned in the very first lecture, trying to understand in theory is not enough. Hands-on is key, and that's why we are doing this challenge task. The key message of this article is to balance reinvention and reuse. Study existing work and reuse what makes sense, but don't avoid building things from scratch out of fear or laziness. The advice here is reinvent for insight and reuse for impact. I think this is a very good quote. The next article is about Bitcoin mining, and it's the following article here. Pakistan has allocated 2,000 megawatts of surplus electricity for Bitcoin mining and artificial intelligence centers. And this is part of a digital transformation plan led by the Pakistan Crypto Council and supported by the Ministry of Finance. In the first phase, the government will direct access power to AI infrastructure and crypto mining operations. And in the second phase, miners will be offered access to renewable energy sources to enhance sustainability in the sector. And now, from what I read between the lines, that means that those 2,000 megawatts will come from non-renewable energy sources, which is something I do not like. And another interesting aspect here is this ranking here. It's a crypto adoption index here from Chainalysis, and they have here a nice map. And Pakistan here we see is ranked 9th in this crypto adoption index due to strong retail adoption and centralized service transactions. Interestingly, Switzerland here is rank 55, but I'm not sure here about the methodology here. They measure the DeFi protocols, and I'm not sure how they measure this on a country basis. And Bitcoin mining, I have here also an interesting graph here. It uses still a lot of energy, around 175 terawatt hours annually, which is here comparable to the entire power consumption of Poland. And if we go down here, when we have the non-renewable energies, here we have the renewables, so roughly 60% of the energy comes from gas, oil or coal. And that's why I like proof of stake much more than proof of work, because I think this is a waste of energy. And if we look at the Ethereum chart, you see here they changed from proof of work to proof of stake, and it's much more energy friendly than this huge energy consumptions from the Bitcoin miners. And the last item is the most important, and it's about the challenge task, which requires students to design and implement a distributed system with servers and events. That includes a front end, a load balancer, 2 service instances, which one being shut down during the presentation to test failover, and persistent storage. All components must be Dockerized and demonstrate load balancing with failover capabilities, service and event communication from server to client, and the ability to handle service instance failures gracefully. And all students need to pass this challenge task to successfully complete the course. And this time I have seen many good projects, many games such as Swindler, Nonorush, Small Brain Duel, and Werewolves, or for example here a platform for Minecraft structures. And also the F1 dashboard was very impressive. And since students could freely choose their tech stacks, I ran statistics for all 21 groups. And here we have the results. Python is the most frequently chosen backend technologies with 10 implementations, followed by JavaScript, TypeScript with 6, while C#.NET has 5, and Golang and Java Spring Boot each have 1 implementation. Traffic leads the load balancer selection with 11 implementations compared to Caddy with 3, Nginx with 2, HA Proxy with 2, Kubernetes default load balancing with 2, and YARP with 1. And from the database side, Postgres accounts for 17 of the database implementations, while front-end frameworks are distributed more evenly across Vue with 6, React with 5. There were also solutions with no frameworks or server-side rendering for Angular with 3 and Svelte with 2, and one group chose Blazor WebAssembly. And now I will reveal the winner of the challenge task in the Distributed Systems lecture in the spring semester 2025. That will get each 50 Swiss francs in Bitcoins. And now I need drum rolls, please. And the winner is Roman Weber, Ramon Bisser with EduCDN. EduCDN is an educational content delivery network. The system provides hands-on experience in CDN concepts, including layer 3 load balancing with BGP anycast, HTTP caching, and real-time monitoring through a dashboard. The architecture consists of multiple distributed components, application layer load balancers, backend proxy servers that can handle cache hits and misses, front-end instances for dashboard rendering, min.io storage for content replication, NSQ messaging for real-time communication, and integrated DNS services. All components are packaged into a single binary with bootstrap configuration capabilities supporting features like split horizon DNS, self-replicating storage, and a web-based monitoring interface that displays CDN events in real time. The project enables you to configure and observe CDN behavior across geographically distributed locations while learning about load balancing, caching strategies, and distributed systems architecture. A very impressive distributed system with many components playing together. Well done and well deserved. Now that was it for the spring lecture. See you in the fall term.